So here's the problem that we will be solving. This is a simplified fleet product. It's slightly simplified to make this demonstration easier to follow. Each policy in this product consists of X buses and Y lorries. And the premium is derived as a base premium for buses multiplied by number of buses, plus base rate for lorries multiplied by number of lorries. This gets summed together and multiplied by a trade or industry factor. And then the whole final premium is subject to a minimum premium. So you can see that this pricing structure is not multiplicative and not additive, it's a combination of both, and it also has a minimum premium. And we will be solving for the parameters in red. So we want to find the base rate for buses and base rate for lorries, and the trade factor and the optimal minimum premium. Now, the added complication in this project will be that the claims data we have for this portfolio is not split between lorries claims and buses claims. This is a very common problem in pricing. So now I'll show you how to price this portfolio. Okay, we will start with data setup and one-way cuts. So let me start building the model in Excel. I open an empty spreadsheet first. Then I go to Add-in and click this button here, this Carver button. This will populate the Excel with a set of template sheets. Here they are. The one we will start with is called Data In. It's a list of policies with claims attached to them. Currently it has some dummy numbers. So this is the actual data for this portfolio in a CSV file. If you can look at it, you'll see the first column is the number of vehicles on that policy. Then the second one is underwriting year. Then let's look at these two. This is number of buses and number of lorries on this policy. And this one shows the percentage of buses in on the policy as opposed to number of lorries. Then you have code ID, trade, and then incurred claims for this policy. So I'll copy the data into Carver. Bang, it's there. I'll also change the formatting a little bit so it's easier to follow. Yes, that's enough. Okay, so then we have 8,000 rows. That's fine. I'll also copy and paste current rates to Carver, just so we have a good starting point. Copy to this new book, create a copy. Here we go, I'll move them to the end. Here we go. So we have data and rates now in Carver. Now I'll take the data and analyze it by some one-way cuts. And I'll start by doing trade. Here I'll select that we want this to be connected to trade, and then I will click Carver. And what Carver does now, it summarizes all, the underlying data by trade. So we can see there are 4 different unique trade values, which is here. These are the 4 unique values of the trade column in the data. So let me go back to the one-way summary. So there are 4 different values. The starting parameter for every trade is 1, and this is the total number of vehicles within each trade. So what I'll do here is I will replace the starting parameter 1 with the actual current rate, and I'll do it using a lookup. So let's look up agriculture and the current rates. There we go. So the current rate for agriculture is 1, and then it's 1 for manufacturing, 1 for retail and services, and 1.3 for transport. Okay, so we have trade. I'll make the same for percentage of buses. And what's this? one and Carver Go. Okay, it's connecting the percentage of buses. Again, there are 4 different unique values. And I'll make another one for trade, which I'll explain in a second why. So trade again. And I'll make one more sheet for global pricing parameters. And the global pricing parameters are these, the minimum premium and the base rates. Okay. So go in here. Fine. The next step is to set up calculations. So let's go back to Carver. And I will start by defining the fleet premium calculation. And I will do this in this data calculation tab here. So this is the part where you benefit from the full flexibility of Carver. Whatever your premium calculation is, you can basically specify it as a calculation in Excel. So anything you can capture in Excel, Carver can handle. So let me show you what I mean. So for example, here the fleet is rated as there is a base for buses, and that one is defined as I'm going now to data. So number of buses times the buses base rate, which is in the rates. And now I'll also multiply it by the additional buses multiplier here now global sheet. So here we go. So we have base rate for buses. Now we will be looking for base for lorries. Oh, sorry, buses single S. So base rate for lorries is number of lorries times the lorries rate times the lorries rate modifier, which you have here. Okay. Okay, now the total premium is buses plus lorries times the trade multiplier. And the trade multiplier is different for every policy, right? Because every policy has a different major trade, some being agriculture, some being services, and so on. So because every policy has a different trade, the correct trade multiplier has already been looked up by Carver and summarized in this sheet here called data parameter. If you look in there, you'll see that there's a trade multiplier. There's as many trade multipliers here selected as there are policies. It's 8,000. Can you see I'm scrolling down right now? So every policy has a correct trade multiplier looked up here. So we'll use it, and then we'll also use the trade additional multiplier, which will be used when looking for the best model. Okay, so we defined base rate for buses, base for lorries, total, and then we need the minimum premium. So the premium is the so far calculated premium and the maximum of that, and the minimum premium from the rates multiplied by the additional factor which will be used in solving. Okay, so that's the final premium. Okay, so we define the premium calculation. So now we can go to the Carver main sheet and reset Carver so it recognizes the work we've done so far. Click. Okay, so that step is completed. Now we will be setting up the calculations in the one-way sheets. So what we have so far, for example, in this trade one-way sheet, we have a list of unique trades. We have the original pricing parameter. We have some constraints. And then we have the solved parameter, which at the moment is the same as the original one. and then we have weight summarized across different trades. But we want also, in addition, to have average premium and average cost and the difference between the two. So let me do this now. I'll start by copying the weight formula into the average premium formula. If you look into the formula window, you can see that it's basically a sum if across the data under the condition that trade equals agriculture. So I still want something similar, but rather than summarizing data weights, I'll be summarizing and calculating premium, which is this. Okay, and also I will divide that by weight to get average. There we go. And then for losses, to get average loss, it will be very similar, except I will be summarizing this. Now you can see how flexible this whole system is, right? You can define your calculations in any way you want, and you can calculate these targets and summaries any way you want. So that's how you can build so many different models. And now the difference between the two, which is the one we will be minimizing, is absolute difference between this divided by that. Or better yet, this divided by that minus 1. Okay, so currently, for instance, for agriculture, the current rates are 27%, 29% of the actual average loss. And now I will make Carver clone these formulas across all the sheets. So it's not just here for trade, but also for the other one ways. So go. Okay, it's doing that and it's done. Now we can make a chart which will summarize this table. And here you go. It shows that we have 4 different trades, agriculture being the smallest one in terms of vehicle count, retail and services the largest. The orange and yellow lines show average premiums by trade type. These two lines now overlap because we haven't started solving the model yet. So straight away you can see that possibly we are overcharging for agriculture and undercharging for transport and construction. Let's make a similar chart here for vehicle type composition. This is the chart. Again, possibly we are overcharging for the fleets with majority of vehicles being buses. We can now move to the last step. First, we have to tell the Carver which one-way cuts should be included in the solving process. So we definitely want to include the trade multipliers. So include. We definitely want to include the globals, so the base premiums and the minimum premium. And in terms of percentage of buses, there isn't really a rating factor for that. So we don't want the Carver to look for a rating factor. So I'll say no change here. But we do want Carver to find other rating factors such that the model will fit nicely for different types of policy composition. So for each of these 4 bands, we want the new model to fit nicely. So therefore, I will select include. Okay, let's go back to Carver and reset it. And this is a really useful thing which Carver does. It brings all these parameters that we care about, which are the 4 trade parameters, and these here into this single sheet. So this way you can use the solver to now find the optimal parameters. So I just hit the solver button, and you can see that the solver is set up to minimize this pink cell prepared by Carver by changing these here, which are the parameters we chose to use in our pricing, and subject to certain constraints which you also specified in the one-way sheets, but they're not essential. So I'll now say solve. And it only takes a few seconds to finish this calculation, and it's based on 8,000 rows. Stop. Okay, and so here are the new pricing parameters. Let's just compare them to existing ones. Okay, so currently the minimum premium is 400,000, and Carver suggests that it should instead be 197,000. And the buses base premium should be 900, and the lorries should be 2,200. And agricultural multiplier should go down, and manufacturing should go down, and retail and services should go up, and transport and construction should almost double. So how do we know these parameters are correct? Well, let's look at the one-way cuts. So for example, for trade, now the red line being the average premium almost completely aligns with the gray line being the average losses. So this is a really good fit by trade. And you can see that the same is true by vehicle composition. So regardless of what's the percentage of buses versus lorries, the model fits average premium very closely to average burning cost. Now you could have more charts like that if there are other rating factors that you care about, but for this demo we'll stop here. So the last question that people asked was, well, how do we know these parameters which fit so nicely, how do we know they don't overfit? And to answer this question, Carver has this functionality of making subsamples. I think I need to save this file though first. So Carver demo, I'll just save it on desktop. And okay, so I just saved this file that we work on, and I'll make the subsamples. This will basically split the data into 3 non-overlapping random samples. So it's happening now. And then once this data is split, we'll then build the same model on each of these subsamples and compare whether the parameters are consistent across all 3 subsamples. So we created the 3 subsamples. You can see them here. They are related to 3 underwriting years. So now that we have these 3 subsamples, let's solve for each of them. Okay, that's sample 1. That's sample 2. And that's sample 3. Okay, let me highlight the results. So parameters built on complete data set were these, and then these here are the parameters from the 3 subsamples. Let's look at, for instance, minimum premium. Well, you can see that each of these 3 underwriting years produce a very similar minimum premium modifier. So regardless which year we look at, the Carver thinks that the premium should be reduced by about a factor of 2. And the same is true for here. It's consistent, here it's consistent, consistent. All of them are. So here we go. These are the solutions from Carver, and they're time consistent, and they fit a model that's nonlinear and non-multiplicative, and it does it using data that is on a different level of granularity than premiums, and it's really quick. So I hope you enjoyed it. Thank you.